Hi, I'm Larry with the Solar Energy Channel, and today we're in Houston, Texas at SEG Solar to give you an exclusive inside look at how solar panels are assembled. Come, let's take a look. So I'm here in Houston with Mark Zapp. Mark is the Vice President of Distribution and Channel Sales. Mark, tell us a little more about SEG Solar.
SEG Solar is a U.S. company. We were founded in 2016 in Pleasanton, California. In that time frame, we shipped over 5 gigawatts of modules in residential, utility, and commercial markets of the industry. We've since moved our headquarters to Houston, Texas, where our factory is. And quality is really the #1 name of the game at SEG. That's what we're known for. I think you'll see during the tour the number of steps we take to ensure quality.
Tell us more about the facility here.
It's a 250,000 square foot facility right now. It's one line running. By probably middle of Q1 next year, we'll have 2 lines running, so we'll be able to go at 2 gigawatt capacity. Right now, we're producing 585 watt modules, and then we'll switch over to 630 watt modules. That'll be produced in the near term coming out of the facility right here.
So there you have it, SEG Solar, US-based company. We're talking US factory, US manufacturing, US jobs, high quality. Let's get into it. Mark, so we're at the first step of the process. Tell us what's going on here.
Right, this is the auto glass loader. So as you can see, suction cups pick the glass up. And if you can think of this process as sort of making a panini. So the glass would be the bread layer. So it's picking it up, removing any excess static electricity, and it's getting ready to put the first layer of EVA on.
All right, so we've got our glass. So what happens next?
Right, so now we get our first layer of EVA. EVA is going to act as the binder, really, of the module. And it's of our panini, it's the cheese of the panini. So the glass comes through, it gets automatically fit and cut button for the EVA layer, and then works through this machine to the flattening machine. So as the EVA layer comes out, it's flat, and all the wrinkles have been removed, so we can move on to the next machine to start looking to get the cells placed on it and soldered.
So this EVA layer, I mean, it looks cloudy. Is that going to stay on the module, or how does that work?
That's a great question. When it gets melted in the laminator, it becomes clear. It melts and acts as like a magic white glue that dries transparent.
Okay.
That's what happens with this. It's a transparent layer, although it looks cloudy and white right now.
Okay, so it stays there throughout the whole process.
Absolutely.
Stays with the module, but eventually it turns clear.
Correct.
Cool. Okay, so now we're at the stringer, and if I understood you correctly, Mark, this is the fastest stringer in the world. Is that right?
Correct. It's the fastest stringer and cell soldering tool in the world. It's 1.3 times faster than the previous fastest. And once we talk a little more about how it works, we can do 9,000 plus half pieces per hour. So it's extremely fast.
Wow, impressive. So let's take a walk through. Show us how it works.
Cells get loaded into right here, as you can see in.
Okay.
They're 182 millimeters by 182 millimeters. So the first step of this machine is they come through and they get cut with a laser into half. So it becomes 182 by 91. Then you can see the soldering mechanism is starting to line up right here. So the cells work their way through. They get aligned to make sure they're in perfect alignment with one another. And you can see the soldering material coming out takes the cells here, solders them together to form the cells into a string. This part of the panini, since we're in the panini talk, would be the meat part of it. It's kind of the crucial part of the solar panel and the most recognizable part as well.
So Mark, if I'm looking for the cells, where do I see the cells here? I see some on the other side.
The cells come through and get onto a rigging machine right here.
Uh-huh.
Then they get taken into the soldering machine right here. So you can see them. They're starting to solder them into strings together.
Okay, so these pieces over here kind of act as a jig to hold the cells together.
Absolutely.
For the soldering that happens here.
Exactly. When they're done, the jig goes back and resets and gets more cells to solder them together.
Wow.
And then you can see them after the soldering is done. Moves the cells to the next step.
So here it's taking that jig off of the cells because the soldering's done.
Absolutely.
And now you have a string of cells ready to go out.
Now you've got a string of cells. you can see here, then we're going to start lining those cells up, the strings of cells, out into this area onto the glass. So if you can think about it, we're building the module from the front to the back. So it's face down, and we're building it backwards, essentially. And so now we got the EVA layer, we've got the glass to EVA layer, and now the cells that are in strings onto the glass, now getting ready to move on to the next step.
All right, so Mark, the last machine that we saw over there put the cells together in a string, soldered them together.
Correct.
Now this machine that you see behind us, it's picking up strings of cells and laying them down in rows to prepare to become a module.
Correct. Yes, this is taking those cell strings, putting them down onto the glass, which the glass is coming this way. All the cells did all their work over there, and now they're meeting right here. Cells are being put onto the glass in the EVA layer right here with this machine. And then you can see this is what comes out after that's done. So you've got glass, you've got the EVA layer, and you've got the cells that are in strings all lined up. The first EL test had already just happened, and that's being monitored to make sure there's no micro cracks, no broken wafers, no false welds. So now it's coming through and getting ready to put the bus bars on, which it'll have 3 bus bars on each of these modules. Modules come through and they spin, and they're getting ready to go through the auto busing machine. And again, you're going to hear the words auto happen quite a bit. Most of what we do here is robotically done, and it's done automatically. So if you look on the other end here, now the buses have been put in. One on the top, one in the middle, and one on the bottom. And you can see the erect ribbons in the middle. That's where eventually the J boxes will go. But you can see now you're taking strings and you're making them into a whole series now, connected together by being soldered and then connected by the buses. Mm-hmm. So now you kind of have a module right now almost. We also have an a taping machine as well. We want to keep, as it moves its way until it gets laminated, we want to keep the cells in perfect alignment. So we move to the string taping to make sure that they stay in place. For when they make their journey, we want to make sure that there's no movement and those cells get out of line, because that could affect efficiency.
Right.
So you can see he's checking here right now to make sure that cells are in alignment. He's adding some labels to them as well. And we move on, and now we're going up to the bridge over to get ready for EVA Layer 2 and second glass.
All right, so now we have the cells all lined up. They're soldered, the bus bars are on, everything's lined up perfectly. So what do we have next?
It's time to add on top of the meat and put the second layer of cheese on. So it's the second EVA layer. So you can see it's perfectly cut, perfectly matches up, even to the point where the 3 ribbons that are standing up on the bus in the middle, you can see there's holes there perfectly waiting. It'll match it up perfectly, and it'll put the EVA layer down and get ready to go off into lamination.
Wow. So
that's the second layer is being placed on. You can see right here, you can see the 3 ribbons in the middle. The holes match up perfectly. It goes through, this could be a backsheet cutter if we were doing backsheets here, but no need for this because it's dual glass. Then it's getting ready to come over for the second glass to be put on. So the last piece of bread on the panini is about to be put on. And you can see in here the process. You've got everything lined up right now. You've got glass, EVA, you've got the cells, you've got the buses, and now you've got EVA, and then the whole panini is about to have the top bread put on it, and the glass will drop onto that, getting ready for another EL test before it goes into lamination. Right here, this is our auto ribbon bending. In order for this to go through to the lamination process, the ribbons that were erect have to be pressed down. So if you can see inside, you can see they're being flattened right now. That's going to enable it to go through the lamination. They'll be brought back up in a few stages down the line. Before we go into lamination, we have our second EL test done. And again, it's going to shoot a current through. We're looking for micro cracks. We're looking for false welds. We're looking for broken wafers. And if there are any issues, then it gets sent off into what we call rework. And they'll diagnose the problem, figure out what it is, send that back to whatever machine it needs to go through again to fix that problem. put it back in line, it'll come through, and it'll go through an EL test again. And that way, we can fix the problem before lamination, because once it goes to lamination, we can't fix the problem anymore. The cells are the way they are as they go through lamination. If there's issues there, it's going to be a false module at the end of the run.
All right, so we're almost ready for lamination. What's the last step before that?
Last step before lamination is the edge taping. So if you can see inside, we're going to tape the edges all the way around it and to seal it off so it prevents any degradation or any moisture from getting through into the cells and really ruining the module. So it's an automatic, again, auto edge taper. So it's going to be taped around the edge. It's going to go through lamination. And then after lamination, that'll be removed so it's a nice smooth edge. So we can add.
It kind of holds it together.
Correct. So you're having the EVA layers kind of melted all together, and the edge really seals it off from elements getting inside. Our lamination machine is the largest one in the world. You can see it's pretty sizable when you walk in.
Wow.
So it takes up a good portion of the hallway right here, but just runs about 150 degrees Celsius. And we can put 9 modules in the bottom and 9 modules on the top layer. You can see them going in. It runs 9 at a time. And it's about 13 minutes that it goes through this process before it becomes laminated. And again, once it's laminated, no more changes can be made internally to it. But you can see it's just feeding now lower level, upper level. And it's going to basically, this is where the panini is going to be cooked. So it's going to cook inside, and then at the end of this, it's going to start the cooling off process.
All right, so at the start of this machine, it's really hot.
Absolutely,
What's the rest of it do? This section right here.
The last quarter of it or so, it starts the cooling off process. There are fans inside, and it makes its way out, and you can see right here, you don't want to touch it because it's still going to be warm, but it's running off, and it's intentionally a long run, if you notice, to get to the next machines. There are fans located underneath that cool it off, going the whole way, so it gives it more time to cool off, so we can get to the point where we can take that excess trim off, the tape off around the edges. But we need to give it a chance to cool down. But you can see it's now really looking like a module. It's getting there. It's almost done. The panini's done being cooked. Now we need to get ready to put it on the plate and get ready to serve it to somebody.
All right, so the module's laminated. Now what do we do?
The auto trimming machine. So as you can see, it's taking the first step is it takes the edges off all the way around, cuts that excess tape and any elements that come out from the lamination process to make it a nice smooth edge. The second version of it is the second trimming machine, and that cuts the corners. It takes the tape off the corners. And we're getting it ready for EL test number 3. So right here is EL test number 3. So it's a nice, bonded together module. The edges are nice and clean. We're going to run it through again. Sometimes when you go through a lamination process, because it's pressed together, sometimes some micro cracks can happen. Sometimes some issues can go on. We want to make sure the modules coming out of the lamination process still intact and still fully functional before we move on and start framing it. Here's another, I mentioned a few times the auto ribbon lead. They were flat back right after lamination. You can see now in the middle there are 3. The ribbons are now erect again. This tool goes down, grabs them. It penetrates, grabs them and pulls them upright.
In the middle.
That's where we're going to get ready to then start putting the junction boxes on. You can't put the junction box on if there's no ribbons coming up.
All right, so we had a module with no frame. Now what does this machine do?
We're going to frame it up. When the module enters into the machine, automatically puts glue along the rails of the frame, and then puts it off into place, frames it up pretty instantly. Now that the module's been framed, we're getting ready to put the J-boxes on to make it really now a module. So you can see it's spinning it, getting ready to put it through. It's going to be glued. The J-boxes will be glued on to where each of those 3 ribbons are pointing up. So they're getting the glue ready to attach the J-boxes on. So this machine will attach the J-boxes onto it. And so this is where the auto J-box soldering is going to happen as well. So you can see they're doing a line scan camera again to make sure they're in alignment. And we'll take a photo. If you look right here, you can see that they're fixed the right way, that the ribbons are going through, and it's getting ready to fill in the glue inside as well, to really protect it from the elements around the edges and on the inside.
So this camera's an extra eye just to make sure everything's placed
Absolutely.
properly.
Yep. It's just making sure, another quality check along the way,
Another
to
double
make sure
check.
that things are in line, things are hooked up the way they should be. Because once you get the glue on, you have to rip that back off if there's a false connection there. This is the potting machine, so you can see J boxes are going there, and that's where the J boxes are being essentially filled in inside the center. What we're doing now too is we're preparing for it to go into the curing room, and to make sure that it's a perfect seal every single time around the edges and inside, so no moisture, nothing can get inside to make the J boxes faulty in any way. So as they're getting ready to go through, this is our curing room. It's the largest curing room in the world. We can run it 30 to 35 degrees Celsius and 65 to 75 degrees humidity. So it's consistent. They can all go through. They don't have to go through individually. They can be stacked to go through, but it gets the same exact drying. We want consistency, quality to be the same every time. So every time it goes through, it comes out the same, all sealed, all the right temperature, and the exact glue, appropriate amount, and the proper curing time to make sure there are no issues with the module when it gets out of the curing room.
So now we've gone through the curing machine. What do we see here?
Right, it's been about 3 hours curing time. So you can see the J boxes are all affixed. There's the seal around the edge. In the middle, there's the glue inside. So we're getting ready to move on to put the lids onto the J box. So the modules will go into the machine, and the J boxes will be put on, the lids will be put on. And really, we have a module at that point.
All right, so we've got a module. Can we go out and install it? Are we ready to go, or what are we doing here?
Almost, we're getting there. We're almost a module right now. Right now, we need to do 3 more tests to get the characteristics of the module, to know exactly what it is we have and exactly what it is we can sell. So you can see a bar is being lowered onto the bus bar and onto the J boxes right there. When we send it to the final 3 tests, it'll hook into there so it can take the measurements. So you can see it's automatically being placed in. It's making sure it's in alignment here as they're being hooked in. You can see they're hooking that in, and they're doing a final cleaning of the module. And the first test that we're going to go through is the IV simulator. That's going to give us the voltage, that's going to give us the wattage, and we're comparing it to a golden module. So a perfect module is in there, and it'll do comparisons based upon that module that's in there. So it'll go through in the sun simulator under STS conditions, and then after that, it'll have a serial number. So we will then be able to track that module all the way to the field. So if there's ever an issue with it, we'll know where it came from and what happened with it. But that's the first test, the IV curve in the sun simulator.
So in the sun simulator, it's at STC conditions. It's at the right temperature.
Correct.
That we see on the module data sheet.
Absolutely.
So when it comes out of there, we know that what the measurements you took here match what's on the data sheet, so we
That's
know that
correct.
we're getting exactly what you say.
That is correct. That's correct. The second test, and it moves quickly onto, is the high pot testing, which stands for high potential. And we're looking for leakage, current leakage, any PID coming out of it, and also frame grounding. We're making sure all of that portion of the module is in line. So we have the characteristics of it. Now we're making sure the functionality of it is up to par as well.
So this is kind of a quality test.
The quality test, absolutely. And then we move on to EL test number 4. Again, doing another scan, making sure everything's all done, everything's finished. We want to make sure there's no broken wafers, there's no micro cracks, no false welds, everything is in line. It is a perfect module when it comes off the line. And it's getting ready to go through just another final camera scan. So we're able to add those images into the MES system. The serial number and characteristics are being added into the MES. Then it's going to go through one more scan, a camera scan. Those images will be added into our MES, and then we'll have that on file. Again, when it's out in the field, we'll know exactly what that module is, what it looked like coming off of the line. It'll get labeled here, and you can see here's the final test. Just takes an image of the module, puts it into the MES, and we come to an end of where we're getting ready to then go sort them by wattage into the appropriate pallets instead of having a mix. So we do have the world's largest sorter as well, and they're going to make sure that they get binned together.
Okay, so at that end, we had a complete module.
Correct.
We're spending this whole line coming up through doing testing. We're testing voltage, we're testing wattage, we're testing in STC conditions.
Correct.
We're doing the high potential test. We're making sure that it's what you said it is and that it's high quality.
That's correct.
And ready for the field.
Right. We're testing all the characteristics of how it behaves under STS to make sure that we can say with confidence, this is what this module is. So when it goes to the customer, we know, you know what you get.
Right. All right, so we've done all of our final scans, all our final tests. So what's this last step?
We're at the end of the line right now. So this is the world's largest sorting machine. So you can see it's bringing them off the line. It's reading its barcode to let the machine know what type of module it is. And it's going to pick it up and it's placing it in the proper bins where it needs to go. After that's done, it'll be in the pallet, will be completed, and it'll be wrapped in film, and it'll be taken out and sent off to customers like yourself so you can install them out into the field.
And that concludes our tour of the SEG facility here in Houston. Mark, thanks for hosting us today.
My pleasure.
There is now more U.S. solar manufacturing today than ever before, and we're here to give you an exclusive inside look. If you'd like to see more videos like this, check out the playlist below.